Well, hello, everyone, and welcome. Thank you for joining today's webinar on the C++ API that's available through Interactive Brokers. Now, I'm very pleased to have with us for today's presentation, Josh, who is a member of our API team. So Josh is going to be taking you through basic information about the C++, and then we'll even take a look at our client test bed that's also available. So with that, I'm going to ask Josh to unmute your phone. I'm going to pass you the ball, Josh, and let's get underway here today. Thanks for joining us, Josh.
Hi, sure, it's my pleasure. Just a moment, see. Okay. Can everyone see my screen?
Looks good.
Okay, great.
And while, just before you start, Josh, if anyone wants to take a look at the screen slightly larger, notice there's a double-sided arrow just above the event viewer where you can simply click for full screen access. Okay, back over to you, Josh.
Okay, hi everyone. I'm Josh. I'm with the API support group here at IB. So this is what I do full-time, is helping people understand our API, what it can accomplish, and helping connect third-party platforms to our API through TWS. Okay, so today I'll be talking about C++ in particular, but most of what I have to say actually is applicable to any of the other API technologies. So we do offer the source code libraries in C# and Java, as well as VB.NET, and all the functions are actually the same in the different programming languages. So there'll be a slightly different syntax for each different programming language, but the functions all look very similar. So once you're familiar with one of the languages, it's actually pretty easy to use another one. It's, for instance, if you want to try it on a different platform, or if there's some other reason you'd like to switch. Okay. So first, I'll be talking about some general characteristics of the API in general, and then I'll talk about where it can be downloaded and installed, and then finally a little bit about the Test CPP client, which is a very simple sample program which is distributed from IB. It can be downloaded from our website. So actually, to use the API, you don't even need to be a client of IB to test it. You can just need to download the API itself as well as Trader Workstation. Both are free to download from our website. So first, I'll start off by showing where you can find those. This is the interactivebrokers.com website. So to find the Trader Workstation download, by the way, so Trader Workstation is the name of IB's flagship trading platform. It's a Java-based program, so it can run on any program, on any platform, that supports Java. So that would be, for instance, a Mac, Linux, or Windows. And all three of those versions are available from our website. So to download it, you just click on Trading and then TWS Software, and you'll see there are a number of different versions displayed. All are fully compatible with the API. And this is where you would download TWS, and it's just a self-extracting installer, which you would run to install it on your computer. I've already installed it here, so this is what it looks like after it's been installed and you've logged in. This is a simulated environment, which means the market data is correct. It's real market data, but everything else is simulated, like the positions, the orders, executions is all simulated. Okay, so that's Trader Workstation. Now, to install the API, it's actually a separate addition. So Trader Workstation by itself can support the API, but it won't install the API just with the TWS download. Okay, so to install the API, you would go to the API Solutions section of the website. So you click on Trading and then click on API Solutions. Okay, and this is just an overview of the different ways to connect to IB. In addition to the API, there are other solutions such as a direct fixed connection. For the Trader Workstation API in particular, you would click on the first link here to learn more about an IB API. This has a broad overview of the different technologies available, and advantages and disadvantages of each, as well as the platforms they run on. Okay, and if you keep scrolling to the bottom, you can see there's a link actually to the API download site itself, as well as to the different reference guides. So in the reference guides, there's actually two different guides here for the API. There's the newer one for version 9.7.2, that's the most recent release, which I'll be talking about today, and also the slightly older, but still mostly relevant, version 9.7.1 release, which you'll find the link to here. Okay. So then to download the API itself, you just click on Get API Software, and that will take you to a non-commercial license agreement, which you need to agree to. There is also a commercial license agreement, which is available upon request. And this will take you to the actual API download site. There are two different versions. One is for Windows and one is for the Mac system. For C++ and Java, actually, they're identical. The only difference is in Windows, there are additional languages available, such as C#, VB.NET, and also the Excel APIs. So after you choose the beta, I'll be talking about the beta today, but you could actually choose any one. They're all functional. The beta does have some additional functions. And install that. That'll create a folder on your C drive called TWS API. I've already done that. So if we go, we can see here's the folder, TWS API. That'll have two subfolders. One will be called samples and one will be called source. So samples is just for the sample code. So we provide a very simple sample program for each of the different languages. And then source is the actual API itself. So there are three source code libraries. There's a C++ client, the one I'll be using today, as well as a C# client and a Java client. Okay. So for the C++ sample, you would choose samples and then C++. You'll see two different sample programs. TestCP client, SSL, is actually still in development. So if you're curious, feel free to take a look, but that hasn't been fully rolled out yet. And then TestCP client is the actual C++ sample application. It's just a very simple finite state machine, which is a console-based application, just to demonstrate the different functions in the API and how they work and the types of data they return. So one of the common questions we get with the C++ API is that there are a lot of references to Windows. Like, for instance, this is a Visual Studio solution file, which is really only used on a Windows system. However, it's a POSIX-compliant C++ API. So how is that possible when Windows doesn't natively support POSIX? And the answer is actually the C++ API can be compiled in either form. It does that through the use of macros, which detect the operating system before compilation and then automatically compile the correct source code. So today I'll be talking about, on Windows system in particular, and so I'll be talking about how to use this solution file to build and compile a sample program. But everything I have to speak about, it would be the same on a different environment, such as on a Mac or on a Linux. The C++ API has been tested on the Mac with C-Lang or on the Linux system with G++. And in fact, you can also compile the POSIX system on Windows if you were to add additional POSIX compliant layers, such as Cygwin is the most common. Okay. So this solution file was designed with Visual Studio 2012. It can be loaded in other Visual Studio versions, such as 2013 or 2015. I'll be using 2015 today. Okay. So after you load that up, this is what it'll look like. So there'll be a solution file. Now have two projects. One project will be actual for the sample program, TestCP client, and the other will be for the dynamic link library, which is TWS socket client. Okay. So this is the actual API itself. By default, it's configured as a dynamic link library, so it'll be loaded at runtime. Whereas it can also be compiled just as a statically linked library, which makes sense for a lot of applications. So actually, when the API is installed on a computer, it will actually install a pre-compiled version of this into your Windows directory of the dynamic link library, so that if you ever use a third-party application, then it could just automatically load that file, which is already installed. Okay. Oh, I should mention, by the way, I saw we had a question about IB Gateway. So anytime I talk about Trader Workstation today in regards to the API, it is also possible to use IB's other platform, which is known as IB Gateway. That can also be downloaded free from our website. Let's see, if you go to interactivebrokers.com, and then you were to click on Login, and then choose IB Gateway. So through the API, IB Gateway and Trader Workstation are essentially identical. The only difference is Trader Workstation has this graphical user interface, which is much more complicated. It allows you to do things manually, as well as to do things like see open orders, to see open positions. So it has those graphical user interface features, whereas IB Gateway is just it's a simpler program, takes about half as much resources, and it does have the ability to run continuously for multiple days at a time. Okay. And so when I'm talking about today the sample client, see that's TestCP client, the code from this is actually taken and used in our new documentation site, which is on GitHub. You can find the link to that if you go to the download site. You'll find it at the bottom here, version 972, the API reference guide. If you click on there, you'll see our new documentation guide. So we have a lot of code samples in here, which are really useful. If you ever have questions about the exact syntax of the function, you can find pretty much all the functions in the API with examples in here. Okay, and you can see we have it organized by programming language. So for instance, if you want to see how to connect in C#, you would click there, and you could see that's a connection call from C#, or in C++. It's slightly different, though very similar. And this would be the syntax of the connection call in an API program. So this is actually taken directly from this TWS C API client. So that's how the documentation side is generated. It uses a system known as Doxygen to automatically include these code snippets from the sample application. Okay. So the first step in connecting an API application after you've installed Trader Workstation is to enable the API within TWS. And there's only one setting necessary to do that. By default, it'll be unchecked, so the API won't be enabled within Trader Workstation. So after you install TWS and launch it and log in, TWS does have to be fully authenticated to use the API. So the API itself doesn't actually handle authentication. That's still only handled through Trader Workstation. And then once it's authenticated and has the API enabled, it'll be listening on a specific socket port for an API program to connect. To do that, you just need to change a single setting. So this is a classic view of Trader Workstation. To get to the global configuration menu, you'll click on Edit, and then click on Global Configuration, and then go to API. So there's a whole section for the API settings. Okay, and choose Settings. And so the first setting here, Enable ActiveX and Socket Clients, is the only one which needs to be checked to use the API. So if you ever install if you ever install TWS on a new computer, for instance, or use a new username, to use the API, you would need to come back in and check that setting. Most of these settings you'll actually never change. They're actually rarely changed by most people. The only ones you would really need to pay attention to are the socket port number, the first setting to enable ActiveX and Socket clients, and also the setting to allow connections from localhost only. Some people like to check. I'll talk a little bit about each of those. So for the socket port number, the API will connect to TWS via TCP socket port. So there'll be a number of different socket ports to choose from as long as one's available on your computer. By default, in the paper trading account, it'll be listening on socket port 7497, and on a live account, it'll be listening on 7496. But those are just default socket port numbers, which can actually be changed and configured to any number that's available on your computer. So that's important to check because the same number here does have to be specified in the API program to connect. Okay, so that's all configured correctly. And by the way, this is also in our documentation guide. We have a picture of that. If you go to the initial setup section, you can see the exact settings which need to be checked to enable the API, and also a discussion of, as I mentioned, the socket port setting. Okay. So once TWS is running and it has the API enabled, then an API program can connect to do things, a number of different tasks, such as, for instance, to request market data, to place orders, to get current account values. Those are the most common tasks which can be automated through the use of an API program. Okay? And each of these has a different section for different sections of functionality which are explained further in the documentation guide. Okay, so in the API there are a couple major classes. There are actually quite a few, but the major classes, one is called eClient Socket, one is called eWrapper. eClient Socket is the class which has all the functions for outgoing messages. That is messages which go from the API client to TWS. So if you open up the source code here, you can find the definition of that class, eClient Socket. So that'll have functions like eConnect. Since eConnect is something initiated by the API program, that's a message which is sent from the API program to TWS. And then eWrapper is the class which has all the messages coming from TWS and being sent back to the API. So those are the two major classes of the API in which you'll commonly be using. So the first function, which has to be called an API program, is this eConnect to create that socket connection to TWS. So if we take a look at our sample program here, it has a main program, and that's just the first function call is eConnect, which just calls eClient Socket with the function eConnect with an eClient socket. So we can take a look here to see, trace where the code goes. So here we are. So, and eConnect has several different parameters: the host, the port, and the client ID. The host is the IP address of Trader Workstation. Some people think maybe it's the IP address of, say, an IB server, but it's actually just Trader Workstation because the API program always has to connect first to TWS. So by default, if it's on the same computer, that can be entered as the number 127.0.0.1, which just indicates that the API client and TWS are running on the same computer. Or in a lot of API programs, it just be null, because that'll be the default. Okay. The next setting is the socket port. That's the one I just referenced. In the TWS settings, that TWS has to be listening on. So right now we have it listening on 7497. We can check that here. So that's the same number we would need to specify in the eConnect call in the sample program. Okay. And if we go back one step, we can see that it is set to 7497 correctly. Okay. Okay, and then finally, the third parameter we have is the client ID. This parameter is used in case you have multiple API applications connecting to one instance of TWS. In fact, you can have up to 32 different applications connected simultaneously. Then each one would have to have a different client ID, and that's just a way to keep them separate so that they're uniquely defined. So this is actually something specified by the API client program. It can be any positive integer. There is one special client ID, which is client ID 0. If you connect with client ID 0, then you'd actually be able to cancel orders, which are manually placed within TWS, or automatically receive information about order status changes from orders placed within TWS manually. So that is the one special client number. That would be client ID 0. But other than that, it doesn't matter as long as they're all unique. Okay. And then the fourth parameter is something which is reserved for future use. At the current time, that'll just always be false. Okay, so the first step is to create a TCP socket connection to TWS, and that's done by eConnect. And after that's been done by the operating system, the next step is to start a background reader thread, which reads for messages coming back from that socket connection and then relays them to the appropriate function in eWrapper. So in the API has a asynchronous architecture, meaning that anytime a message is sent from an API program to TWS, it doesn't wait for something to be returned. The main thread will automatically continue to the next task. So for instance, if it makes a market data request, it just sends that message to request market data and then automatically continues. Market data can be streaming sometimes for hours on end, so it wouldn't want to wait until all market data is returned before continuing. So because of that, because of the asynchronous architecture, pretty much all API programs will have at least two threads. There will always be one thread, the main thread, to send messages from the API client to TWS, and then a background thread to continually process messages coming back. So that eReader thread is that background thread. It will check the socket for messages which are being returned, and then what it will do is put them in a queue and then send a signal to the main thread to say, hey, there's a message waiting to be processed. So this is what is happening in the background in that eReader thread. Okay, and so you can see the second parameter in the constructor for eReader is actually that signaling object. So this is that signaling object which will be used to signal to the main thread that there's a message in the queue waiting to be processed. And then our main thread will just, in the sample program anyway, it will just sit and wait until it gets a message that there's something waiting in the queue. It will then process that message and send it to eDecoder. eDecoder will just make it easier for the programmer because it will decode it from a number to a string. For instance, if it sees a number like, say, 5, it will interpret that to mean order status and send it to the order status callback within eWrapper. Okay. So the first step in the program then is to connect and to create this background thread. And then after that, the next step which happens in an API program is initial handshaking. The handshaking is a way to check the maximum version supported by both the API and by TWS. So API and TWS both have a number of different versions, actually a large number, and each new version supports additional functions. So this initial handshake mechanism is a way to tell which functions would then be supported both by TWS and by the API. TWS is very good about being backwards compatible with the API, which means if you have a previous API version, you can always update to the latest TWS and not worry about API compatibility. So even if you have, say, an API version from several years ago, that would be compatible with the most recent version of TWS, which can be downloaded from the website. Sometimes, in the opposite way, it doesn't always work, because when new functions are added, at first anyway, they'll only be available in TWS C beta until the older versions catch up. Okay, so in an API program, while that handshaking mechanism is taking place, it has to be careful not to make any function calls in the meantime, because it has to wait until that process is completed. So one way of checking for that is to wait until something called the next valid ID is passed back from TWS to the API program. So that'll be a way to signal to the API program that that handshake mechanism is complete and that it'll start relaying back information. So at the start of every API program, two things it will always relay back are the managed accounts list, that is the list of accounts which this TWS user has access to, as well as the next valid order ID. So if we take a look within our program here, we can see we have a function next valid ID, which is down here at the bottom. So this is where the initial callback will begin and start the initial state of our simple sample program here. The next valid order ID is important, by the way, because every time an API program places a new order, it has to be with an order ID greater than all previous orders. And that has to do with, that way it doesn't have to ping the server every time to see what the next order ID is, and if it's a unique one, it'll just keep track of it. Otherwise, it would add too much latency if it had to ping across the network. So this is where the initial state of our program is set. It will sit in the next valid ID message callback and set that state of the program. And then the way the sample program is set up is just by areas of functionality. So for instance, there'll be an area of functionality, say, like if you want to see the different functions which are applicable to, say, financial advisor accounts, there's a function just for that, and it has all the functions that would apply to that within this sub-function. So in our API program, the first thing, if we want to test, say, market data, what you would do, you would comment out that state, and then uncomment the state for market data in particular. Okay, and what that will do is in the initial steps of the program, after the API gets the signal that TWS is ready to start receiving commands, it will then set this state and then go to that section of the code that deals with market data. So I'll scroll up to that, which is way up at the top here. Okay, that's tick data operation. And then in this function, you can see we have a number of different examples of ways to request market data from the API. So this is the function for real-time level 1 market data. So that's things like the bid value, the ask, the last, high, low, close. Those are all things you can get in real time. Okay? And you can request market data through the API for pretty much any instrument. There are a couple exceptions, but pretty much any instrument. If you have real-time data in TWS, you can expect to get real-time data also through the API. To get real-time data in TWS does require market data subscriptions, which usually have small fees involved. There's more about that here on the documentation guide about how to get live market data. Basically, you would need to log into a live account and go into account management and then sign up for the market data subscriptions. Since for most market data subscriptions there are fees involved, then you do need to have a funded account to get market data through the API because it requires somewhere to take the fees from in order to get that live market data. Okay, so that has more about that here. Okay, and then also about the request market data function. So IB's market data, it talks about in our documentation guide, isn't exactly tick by tick. So you won't receive information about every single trade through the API. You receive what are called snapshots, which are just statistical snapshots, which for stocks occur about every 250 milliseconds of activity on the market. And this is the market data function call. It has a couple different parameters, which I'll go over. So the first parameter in the request market data is what's known as the ticker ID. This is just used as a label for each market data request because you can have quite a few going at the same time, and data will be returned through a different function. So when that data is returned, they'll have this same ticker ID to indicate which market data request resulted in that data being returned. So these just have to be unique, but again, they're just anything which can be chosen by the API program. Next would be the contract object. The contract object is one of the fundamental classes of the API, which I need to talk about a little bit more. So through the API, from a programming perspective, each different instrument is called a contract. So this is a little different than the financial contract. From a programming perspective, what's called a contract can be anything like a Euro-USD Forex pair, as well as an option contract, futures contract, a warrant. Each of those would be a different contract object. So in the API, there are many different ways to define a contract. We have some examples here in a file called contract samples.cpp, different types of instruments and the ways they can be defined. So for instance, this would be for a Euro Great British Pound pair. You just need these 4 parameters and create a new object of this class. And then you would pass in that object to this rect market data function in order to receive real-time streaming quotes about this currency pair. So one of the most common questions we get to the API support is how to find the parameters for a contract. The easiest way to do that actually is just to enter that contract into Trader Workstation to make sure it's the correct one and all the quotes look right and everything. And then to right-click on it and go to Contract Info and then Description. And that will give all the parameters for a contract. Most importantly, the ticker name, security type, currency, and exchange. For most contracts, you'll need those 4 parameters commonly to define them. So the underlying through the API will be what is called the symbol field. So for instance, for the interactive broker stock, the symbol would be IBKR, security type would be SDK, and then exchange would be SMART. SMART refers to IB's proprietary algorithm for routing an order to multiple exchanges, and it does that based on likelihood of execution as well as best price. So this is most commonly used, but you can also direct route the request or an order by just defining in that name in the exchange field. Okay. So in our example here, in our market data example, so in contract samples, you can see if you ever have a question about how to define a different type of instrument, you'll probably be able to find that instrument here with an example in the contract samples class. And then in our sample program here, we're requesting data for European stock. And then so the third parameter after that contract's been defined, which is defined in this sample contract samples.cpp, would be the generic tick list. So anytime a market data request is made, there will always be certain fields called fields called default ticks, which will always be passed back. So to get some examples of those, we have a section on that in our documentation guide. Okay, so anytime you see that generic tick is not required, that means that it's a default tick type. So it will always be passed back for any market data request. So these are the values which will always be passed back. You would get, for instance, a bid size, a bid price, ask size, ask price, and so forth. But then there are also certain special tick types which will always only be passed back upon request. For instance, like if you want dividend information, or if you want, say, any of these other values like the mark price, or there are many different types of tick types, then in the generic tick list you would have to specify a certain number. And so that's the third parameter in our market data request. In this example, we're just going to leave that null, so we'll just receive back the default tick types. And then the fourth parameter in our market data request is a Boolean value, true or false, which indicates whether or not we want snapshot data. So if it's a true, that means it would be a snapshot request, meaning you only get at most one value for each field of the default tick types, and you won't continuously receive data through the API. If it's false, then you won't be subscribed to data, meaning it will be returned continuously until it's canceled. Okay. So by the way, there are a lot of different examples here. So if you ever want to test out any of these other examples, you just need to uncomment the relevant code line so that it's invoked. So in our example here, we're just going to show what the data will look like for when you make a market data request for a European stock. To see which European stock it is, we'll take a look at the definition. So this is the stock SMTPC, and we're specifically routing this request to the Batin exchange to get data specifically from that exchange. An important test to do first to make sure that we get live market data through the API is to check whether that same live market data is also available within Trader Workstation. Okay, so we can do that just by going into TWS okay, and then putting in a ticker row with the same ticker. So if you enter an SMT PC into a ticker list in TWS, you can see it'll give you a couple of options. You can either smart route to stock, which means it'll look at multiple exchanges on which it trades, or you can direct route to a particular exchange. An important point in requesting market data is that a lot of times exchanges would have their own individual market data subscriptions. So you might be, say, subscribed to one exchange but not another. So for instance, in this test account, there's a subscription to these first two exchanges, but not to this third one. So if I hover my mouse, I get the pop-up that says delayed market data, that says it only has delayed market data. So when you request market data from the API, that will give a very common error message, which has error code 354. And I should mention that the error codes, which are very commonly received and very useful in troubleshooting API programs, are defined in our documentation guide. So we have a whole section here on error handling, especially on the different codes. Okay, so for instance, for that one I just described, the 354, market data is not subscribed. If you ever receive that, you could open up the documentation guide and go to that section and find an explanation of what it means and also how to resolve it. Okay. So let's see, I'll go back to the test suite client, and then I'll run this program, build and compile it. Okay, I'll take just a moment. Okay. And so that will automatically build and then execute the program which is built, and this is the output from our sample program. So in our sample program, it doesn't really do anything other than just output the data to the screen just so we can get a sense of data that's being returned. So you can see the first things returned in any API program after you connect, as I mentioned before, would be the managed accounts list. So that's the account numbers which this TWS has access to, and also the next valid order ID. Okay, and then these characteristic messages will always be passed back, which just say that the market data farm is okay, that is, you connected okay to the servers. So this isn't a true error. You can tell because it has error code -1. It's more just a notification indicating that it's some information which the API client might be useful for the API client, in this case that you've connected okay. And so after that's done, then the only thing our sample program does is execute this one market data request. And then you can see the type of data that will be returned. So anytime you get a -1 value back for market data request, what that means is there's no data currently available. So most commonly that will be because the exchange is closed. And in fact, for this contract, it is currently closed because it's a European stock. So that's why it's not trading and you're not able to receive any values. You do receive the field type 9, which is the last price. I'll show you where that can be checked. If you go down to the tick type definitions, you can see, oh, sorry, actually 9 is the close price. So 7 would be, last would be 4, close would be 9. So you can see the close price, so that will still be available. But other things like the bid and ask won't be available since the market is currently closed. Okay, and then I'll show another example. Okay. So if we try another example here, that was for a European stock. Let's say we want to do a U.S. stock. So this is actually, I think, Interactive Broker stock. Let's see. Yep, so this is an Interactive Broker stock. And this is a direct route request to the Island Exchange. Through the API, this does trip people up a lot. Island is the ECN for NASDAQ. So anytime in the API you want to specify NASDAQ, you would actually write the word Island. Pretty much all the other exchanges would be exactly the same as they're usually called, except for NASDAQ, which is Island through the API. So this is a direct route market data request to the Island Exchange for the Interactive Brokers ticker. Okay, and in this case, we're actually going to specify a couple of generic tick types. So we're going to specify 233, 236, and 258. So we get extra data back beyond the default tick types that are always returned. So to check to make sure we have the market data subscriptions for this, we can just go into TWS, enter in IBKR into a ticker row, and then do directed to Island, because that's where our market data request is going in this example, and make sure that you can receive live quotes. So these are live quotes. You can tell because of the bright green color. If it's bright red or bright green, that indicates it's a live quote. And also in a live account, if you hover your mouse over a quote and it and it gives an option to launch the market data subscription manager, that would indicate that there's no live quotes available and you need extra subscriptions. Okay, but we do have live data in this case, so we'll be able to receive live data from the API. So after we've uncommented that, I can run the sample code again. Okay, and you can see in addition to the usual take types, which we always receive, we also receive extra data back. In this case, this is the fundamental data. So this is Reuters fundamentals. If you ever want to have additional information from about a specific security, like say the price-to-earnings ratio or things like that, you can get that from the Reuters fundamentals by specifying a generic tick type. So there's more about that in our documentation guide. Under the fundamental ratios, you can see they're all defined here, all those codes and what they correspond to. Okay, so that's requesting market data, and you can see it'll keep updating in real time as you continue to receive new quotes until it's canceled. Okay, so next I'll talk about a little bit about placing orders from the API. It's very commonly done to automate order placements from the API. So to do that, we'd have to go back to our sample program if you want to demonstrate the order functionality. Go into the next valid ID, recomment the tick data operation, and uncomment the section for placing orders, which is under order operations. Okay, and then we'll scroll back up here to go to the sample code where the examples on placing orders is. There we are up here. And this gives a lot of different examples on the many different order types available through the API. So IB has a huge number of different order types available, as most people are probably aware. These can be found descriptions from our website. If you were to go to our website and then go to, okay, and you would click on trading and then order types and algos, and you can get definitions of all these different order types. And through the API, it'll be just the same. It'll be the exact same order that you would place from TWS. Only difference, of course, is that from the API, you can automate it, so you can place it automatically based on different conditions or based on your own customizable logic. So many different examples we provide in this sample class called order samples. If we want to take a look at that, okay, so this is order samples.cpp. And this has examples of many of the different orders that are offered from the API. These are also on the documentation guide. There's a whole section for placing orders. So if we go back here, so this has examples. This is all taken directly from the sample guide, so you see it corresponds exactly to this sample code, and that's where it's taken from. And it has examples of how to place many of the different types of orders through the API. Okay. So in this example, well, first I should go over the parameters in the place order command from the API. So the first parameter, as I mentioned before, would be the order ID. The order ID does have to be increasing with every new order placed from an API client, and that's just to uniquely label this order. It's important from the API perspective because to modify an order, you would actually just place the order the same way with the same order ID, but with a slightly different parameter. So that's a way which TWS can detect if it's an order modification or if it's a completely new order. So if it's increasing and it's greater than all previous orders, that tells TWS, hey, this is a new order, and to place it as such. So in a simple program, you can actually just have a global variable, which is incremented on every new order that's placed, and that's how it's done in the sample API program. If you were to have multiple API clients connected to one instance of TWS, it would get more complicated, and you probably would have to make some adjustments. Okay, and then the next parameter, again, is that contract object. So this is defined in the exact same way as it was defined before in the market data request. It's just a contract object, meaning any type of contract, not just say an option contract, but like if you had a Euro-USD currency pair, that would be a contract object. And that's the second parameter in our place order command. And then finally, we just have the actual order itself. So for instance, this defines if you want a limit order, it would define the limit price, the time in force, and also if it's a limit order or say a market order, that would all be defined within this order object. So for this example, the U.S. stock again, that's IBKR. So we're placing an order here for IBKR, and we're placing 1 share at a limit price of 50. So if we go in here, you can see exactly where that's defined. So you can see this is where we define that it's a limit order by specifying LMT. We specify the quantity, and then also the price is 50. So what we're saying here is we want to place an order to sell 1 share of IBKR at a price of 50. Okay, so then if we just execute our program here, okay, and then after it's placed, you see we get an order status callback. So this will always be returned with the current status of the order. For instance, if it's been submitted, if it's been filled, or if it's pre-submitted, you would receive that back from TWS automatically after the order has been placed. And we also receive a callback to open order with details about the order itself, as well as the contract the order is placed for. So then in TWS, which is really useful for troubleshooting, because it will actually show this order, it will appear here, and also appear on the API tab. So anytime you place an order from the API, it will create this tab API automatically and place the order on that tab. So we can check the parameters to make sure they match the parameters as they're specified from the API, and you can see it's the exact same. So we're selling 1 share of IBKR at a limit price of 50. And also important to note, this is a direct route order to Island, so it's not smart route, it's direct route to a particular exchange. Okay, and then if you want to test a different type of order, a different type of contract, again, all you would need to do would be to uncomment that section of the code here, which shows a lot of different examples on placing orders. Okay. I should also mention that, in placing orders, the associated functionality would be to receive information about open orders. That is documented in our guide here. So the first section is about placing orders, and then under order management, there's information about modifying orders, which I mentioned is done by specifying the same order ID as the original order, and also to receive information about active orders, which can be done with functions such as request all open orders and request open orders. So if you want information about orders which were previously placed, you would call one of these functions. If you want just information about the status of an order as it changes, so for instance, if it were to go from submitted to filled, for an order placed from that same API client, you wouldn't even need to call one of these functions. That would be passed back automatically. Okay. Oh, and then one other important thing with placing orders, there are a couple important TWS settings which affect order placement. So if we go back into the API settings in TWS Global Configuration, we'll go to Edit Global Configuration. One important setting is the read-only API. So by default, this will actually be checked like such, indicating that the API can't be used at the current time to place orders. It can only be used to do things like read account values or read market data. So if this box is checked, you won't be able to place orders, and then you'll need to uncheck it in order to place orders from the API. Okay? And then in terms of placing orders, another important setting is the master client ID. So this is important because by default, a client will only receive information about orders placed from that client. So if you wanted to receive information about all open orders, then you would need to set it as the master client ID, indicating that it should receive information automatically about order status changes for all open orders. Okay, and then also there's a setting on precautions in placing orders. So this applies to specifically placing orders from the API. So in TWS, it has a number of different precautions, which are basically used to make sure that if an API program, has a bug or it's still being developed, that it doesn't submit a crazy order, which, say we're to sell 10,000 shares of IBKR when you meant to sell 1 share. So it has precautions in TWS, which automatically limit that. And to automatically bypass all those, you need to check this box to bypass order precautions. Otherwise, certain orders would be delayed, and you would see them appear in TWS with a T for transmit button, which means it hasn't been transmitted because of the order precaution setting. Okay, so that's an example of placing orders from the API. And then finally, I'll just talk briefly about requesting account values, which is also one of the most common tasks the API is used for. Okay, so back again in our sample code, to show the section on requesting account values, we would comment out the line, the state for order operations, and instead uncomment the one for account operations. Okay, and then if we scroll up here to that section of the sample code, okay, this is account operations. So this shows all the different functions available from the API to get information in real time about your account. So the most common functions used are this one, which I'll demonstrate, account updates. So account updates will do is subscribe automatically to updates about account values. So if you invoke this function from the API, it will automatically receive updates about both account values, things like current net liquidity, current cash available, as well as things about current positions, so all the current positions in your account. And once the subscription is made, that will continue. You will continue to receive updates every 3 minutes until that request is canceled. So what this does basically is just pull data directly from this Trader Workstation account window. So in TWS, if you go to Account and then Account window, you can see all the values in your account, both account values like your balances, your cash and net liquidity, as well as your current portfolio. And so the API, what it does, it just takes the information directly from this window. And as you can notice, this doesn't update like every second. These values will typically only update when there's a position change or otherwise every 3 minutes. So the frequency from the API will be just the same. It'll occur every 3 minutes. Okay, so the parameters in this function call are just the first one is true, and that indicates if you want to be subscribed to data or to unsubscribe. And then the account number, it can only be used with one account at a time. I only have an individual account, which means it only has one account number, so I can leave it as null. But if it were, say, a financial advisor account, then you would have to specify the account number to receive updates about from this function. There are other functions which can be used with a FA account, such as rec account summary, which will give information about multiple accounts, as well as rec positions. But this function in particular only gives information about one account at a time. Okay, so I'll just run my program to show what the results look like. Okay, so when this function is called rec account updates, it has 2 callback functions associated with it, 2 main ones. The main one is update portfolio, which gives portfolio information, and then also update account value, which just gives account values, all the different account values in your account, things like total cash balance, unrealized P&L, or net liquidity, as I mentioned earlier. This is in our documentation guide if you'd like to read more about it. There's a section here for account updates. So here's the syntax of that function, and then also the functions which are the callback functions which will receive data after a subscription is made. So that would be the update account value and the update portfolio. Okay. Okay. That was most of what I wanted to go over. Were there any questions to answer or any other suggestions, any demonstrations anyone would like to see? Let's see. Okay, I'll mention a little bit about financial advisor accounts. So the API is fully compatible with different account structures, such as a FA or financial advisor account. The functions would be a little bit different for some functions, like if you wanted to place an order from a financial advisor account, then you'd either need to specify a single account if you want to go to a single sub-account, or to specify a FA group or profile. Most typically, those groups or profiles would be set up directly from within TWS, and then the same name would be used from the API. So it is possible with these functions, such as request FA, to get information about your current accounts, your current groups and profiles in an FA account, and then to use that same information to place an order from the API to a group or a method allocation. Okay, but other things from an FA account, say like requesting market data, would be exactly the same. And then if you want to request current account values with a financial advisor account, you would need to use a different function most typically, such as rec positions or rec account summary. So if I go to that section of our documentation guide, so in rec account summary, what that will do will give information about all the sub-accounts. So it's a slightly different function. And then how you do it, you specify the list of tags you want. Tags are things like net liquidity or total cash balance, as well as the group you'd like to subscribe to. So you could do it for all, but you could also do it if you just want information about a specific group. You would specify a different group name here, and then you would receive information back through the account summary function, which would give current account values for all the accounts in that group. Okay, and then positions is similar, except it's just for positions. Account summary would just be for account values, but positions would just give you information about all sub-accounts. So that could be used in FA account structure if you have multiple accounts and you want to receive information about all the sub-accounts simultaneously. Okay. Okay, I think that's just about all the time we have for today. Cynthia, was there anything else I should mention?
Well, Josh, thank you very much. Now, we are going to be concluding the event, but before we do, I actually do have one piece of business that IB's management requires in each event. So, and that's a poll. I'm going to be opening up a polling panel on your screen with 3 short questions, and I ask that you just take a moment and make your selections, and then make sure you click the Submit button in the lower right-hand corner. By the way, question number 2 has an input field, so if you have any comments or suggestions on other topics you'd like to see more about, then that makes a great place to put it. Only about 5 seconds left, so please finish up, everyone, and use that Submit button. Thanks, all. It is very helpful. Poll has just ended, so I appreciate that feedback. And if you do have those questions or suggestions, you can always send them to me at webinars@interactivebrokers.com. Now, I see a couple of other questions might be coming in now. So, by the way, you can remove the polling panel or simply double-click the chat panel, which is just turned orange in your panel screen to get back to any of those questions. Now, also, before I hand this back over to Josh, I saw a few questions come in. We have been recording today's event, and each of you will get a direct link to today's recorded playback soon after the session ends. And by the way, as you exit today's presentation, you'll also get a link to the documentation that's available on the Interactive Broker website. But Josh, if you could walk us back through how to access that documentation and then handle those few extra questions that came in before we do wrap it up.
Oh, okay, sure. Okay. Okay, so to get again to the GitHub documentation site, the easiest way to get there is if you get to our website at interactivebrokers.com.
Josh, looks like you have brought us to full screen on the event viewer. If you could go back and go to the blue bar on top, hit the return button, and then take us into your desktop. There you go.
Oh, sorry. Okay.
That's okay. And then share your screen or share my screen, I think is from the file menu. There
oh, okay. There we are. Is that better? Okay.
Now we can see it. Thanks.
Oh, okay. Perfect. Okay. So again, this is the Interactive Brokers homepage. To get to the API section, you would click on Trading and then API Solutions. And then for the TWS API in particular, you would click on Learn More About IB API. And then from here, you'll find the links both to the documentation and to the API download. At the bottom is a link to the documentation guide. So if you click on API GitHub Guide, that's the most recent version of the documentation. Okay, and there you can find sample code for pretty much all the functions in the API in each of the different programming languages. Okay, and let's see if we have some more questions here. Okay, there's a question about some indicators from the API. If you can get indicators or statistical indicators. So the data returned actually from rec market data is actually just raw data. It's just raw data values like the bid, the ask, and last value. So from indicators, unfortunately, you couldn't receive those directly from the API, but it would be possible, it should be, to create those in the API client program using that raw data. In fact, there are some third-party programs out there which do exactly this. They'll use the raw data returned from the API to create their own indicators, but that it wouldn't be directly available from the API itself. Okay, let's see. There's a question about, CFDs. CFDs are fully supported from the API, just as in TWS. If you have trading permissions for CFDs in TWS, you could also trade those from the API. They're very easy contracts to define. Basically, you would just need to define the contract security type as CFD instead of SDK for stock. And we should have an example of that, and we do here. So define CFD, and here would be an example. You would just use the ticker symbol, security type CFD, and just the other normal parameters. One thing I should mention is for market data, IB only provides actually market data for index CFDs. There isn't separate market data for stock CFDs, so it would just be the market data of the underlying stock which would need to be requested. Okay. Oh, okay, there's a question about pair trades. That's a good question. So in terms of contracts from the API, a contract object could include something like a future spread, like if you want to do a January, February crude oil future spread, that could be defined as a contract. So that would be under our spreads here. If you go under future spreads, you can see examples of how to define different types of spreads. For instance, like a future spread, or you could do an option combo. Like if you wanted to trade, say, an iron condor, you would define that as a combo option object, and then it could be traded from the API. You could also request market data for it, and that would be the same as functionally as trading it directly from TWS. Okay, there was a question on historical data. So historical data is also available from the API. I didn't really have time to get into it today, but it's certainly available. You do need to have market data subscriptions in your account to get historical data from the API. And then we have a whole section on that here. If you go under market data and then historical data, it talks more about how to make a historical data request and how they will be returned. So for the past 6 months, the smallest bar size you can receive would be 1 second. So you could receive 1 second bars up to the past 6 months for most contracts. And we do provide historical data for most types of instruments, such as currency pairs, stocks, futures, anything like that, except for unless it's like an expired option, in which case there wouldn't be historical data available. But in general, for historical data, it actually just pulls the same data from a TWS chart. So if you can chart something in TWS, the vast majority of the time, that same data would be available from the API, because it'll actually pull this data and it'll match exactly what's seen in a Trader Workstation chart. Okay, I saw a question about differences between trading a live account and a paper account. So from the API, we actually recommend the clients first trade in a paper trading environment. From the API perspective, it's essentially identical. There would be no difference. There are some limitations of the paper account itself, such as certain order types which aren't supported. But aside from that, it would be just exactly the same. So that's why we actually recommend to first test API programs in the paper trading environment before moving into production trading. Yeah, I think that should pretty much do it. It looks like most of the questions I see here.
Well, excellent, and thank you so much, Josh, for today's presentation. As a reminder, we have been recording, and everyone watch your email later on this afternoon. If you do want to come back and review those concepts that Josh went through today, you'll be getting a direct link to today's recorded playback. I also want to tip my hat to Stephen J. for joining us today. Stephen's also a part of our API team and has been answering your questions as we're going through the chat panel. By the way, as you do exit today's session, I do have a link to the API documentation that will pop up on your screen, so you can bookmark it from there to access whenever you're looking for additional information. So with that, we are going to conclude our event today. And by the way, I also want to let everyone know, I saw a question come in before about the Java API. Josh is actually going to be covering that coming up in January. On the 24th, we've just posted next month's webinar, so you can find that on the Interactive Brokers website. Underneath the education menu, you'll find a webinar section where there are several tabs across the top. Now, if you go into the recordings and into the API tab, you'll find today's playback, but also if you go into the live sessions and again under the API tab, you'll be able to register for next month's session. So with that, I want to thank each of you for joining us here this afternoon. Have a great day, everyone, and please all remember to trade smart. Thanks all. Special thanks to Josh and the API team for a great presentation. Thank you all. Have a good one.
Take care.